Hi, this is Fazana again. I hope you've watched my videos on similar shapes with the scale factor length only before you watch this video. It's a process whereby you can feel yourself getting smarter by rising level by level. In this video, we will learn the connection between lengths, areas, and volumes of similar shapes and how to calculate the areas and volume. Let's learn through some examples. Okay, I hope you like the balloons, just something nice and colorful. They're all similar. Okay. Two solid shapes, A and B, are mathematically similar, and the base of A is with a radius 4, and the base of B has got a radius of 8 centimeters, and the surface area of shape A is 80 centimeters squared. Okay, so let's find the scale factor of the length, which is 8 divided by 4, which is 2. Okay, so the scale factor of the area will be 2 squared. Alright, and I'll just show you an example. If you have a square of 2 by 2, and then you draw another square of 4 by 4, the area of that shape would be 4, and the area of that would be 16. And so you can tell the scale factor of the length is 2, but the scale factor of the area is 16 divided by 4, which is 2 squared. Yeah? Because you're taking multiplying a length with a scale factor of 2, and then multiplying another length with a scale factor of 2, so the scale factor of the area becomes 2 squared. Okay? And while we're at it, we'll just put the scale factor of the volume equals 2 cubed, which will be 8. Okay, yeah, as easy as that. Okay, so if the surface area of shape A is 80, the surface area of shape B would be the 80 multiplied by the scale factor of the area, which is 4. Yeah, so that's scale factor of area. And you get 320 centimeters squared. Okay, now if they're saying the volume of B is 600 centimeter cubed, now because we're going from bigger to smaller, we're actually going to divide by the scale factor of the volume. So you've got, let's put it here with more space, so you've got 600 divided by the scale factor of the volume, which is 8, and 600 divided by 8 would give you 75 centimeter cubed. Okay, so that would be the volume of 75 centimeter cubed. So this would have an area of 320 centimeters squared. Okay, and sometimes I really do put the answers here just to make sure that it's reasonable. I've done it the right way. I haven't divided instead of multiplied. Yeah, all right. Okay, that's quite simple, isn't it? Once you've got your scale factor, then you just go and you can find the scale factor of the length and the volume if you have the scale factor of the area, and the other way around. Okay, yeah. Okay, two cones P and Q are mathematically similar. The total surface area of cone P is 24, and the total surface area of cone Q is 96. So immediately, I just go find the scale factor of the area, because that's what we're given. Yeah, and it'll be 96 divided by 24, which is 4. Yeah, so immediately I just go, I know the questions are coming, so the scale factor of the length is the square root of 4, because you know the scale factor of the area is the scale factor length squared. Yeah, so that would be 2. and then the scale factor of the volume, now I'm just getting carried away, so that was 2 squared. So then the scale factor of the volume would be 2 cubed, which is 8. Okay, again. Okay, so if the height of cone P is 4, then the height of cone Q, yeah, would be 4 times the scale factor of the length, which is 2. So that will be 8 centimeters. All right. Okay, then they say the volume of P is 12 centimeter cubed. Right, 8 there. Okay, so what's the volume of Q? So now we know we've got to play around with the scale factor of the volume. So we just go 12 times 8, which is the scale factor of the volume, and we get 96 centimeter cubed. Okay, so if you've prepared that, you can tell your workings will just flow and your answers will come out, yeah, quite effortlessly. All right, next question. Okay, shown below are 2 mathematically similar cuboids. The volume of cuboid B is 1728 centimeter cubed. Find the volume of cuboid A. Okay, so we've got the lengths, the corresponding lengths. So the scale factor of your length would be 24 divided by 4, which is 6. Yeah. We won't need the area, so we can immediately go scale factor of volume equals 6 cubed. So that's the scale factor of the length cubed. All right. Here we're going from bigger to smaller. So the volume of cuboid A would be 1728 divided by 6 cubed, and we get 8 centimeter cubed. All right, okay, as easy as that. Really easy, 3 marks. Okay, all right, this one just looks a little different. Steph is solving a problem. Cube A has a surface area, and it's a cube, okay, has a surface area of 150 centimeters squared. Okay, as I read, sometimes I just start calculating a bit. If it's got an area of 150 centimeters squared, then you can tell that the area of each face would be area 1 face would be 150 divided by 6, which is 25. So you can tell if the area of 1 face is 25, then each length would be 5. Okay, so you can tell that's 5, 5, 5. All right, yeah. Okay, cube B has sides half the length of cube A. Okay, so sorry, that was 5, 5, 5. Let's go again. It helps to read it. Okay, half. 2.5, 2.5, 2.5. Yeah, all right. So that's cube A and that's cube B. Okay, what is the volume of cube B? Oh, that was easy, wasn't it? So the volume of cube B equals 2.5 cubed, which is 15.625 centimeter cubed. Okay. Now let's just say, to solve this problem, Steph decides to halve the surface area. Okay, but he wasn't supposed to halve the surface area because we were supposed to halve the lengths once we got the lengths. Calculate the square root of the answer. we were going to calculate the square root of the area of the face, so you can tell that was not what he was supposed to do. Then divide by 6, so you can tell we had to divide by 6 first. Yeah, and then we were going to square root the answer. Yeah, and we weren't, once we'd found the length, then we were going to half the length, not the surface area. And then we would cube the 2.5. Okay, so you can see he just didn't do it in the right order. All right, and that explanation itself would be fine. All right, okay, cool. Okay, next question. Okay, two spheres have radii in the ratio 5:3. Circle the ratio of their volumes. So you can tell again the ratio of their lengths is 5:3. So the ratio of their volumes would be cubed. Yeah? So you've got 5 cubed to 3 cubed. And 5 cubed is 125. And 3 cubed is 27. Okay? So that's the correct answer. All right, yeah? So no matter how the questions are phrased and how they try to make it look a little different, as long as you're following the scale factor of the length, scale factor of area is squared, scale factor of volume is cubed, then you can tell your workings just flow. All right. Okay, 2 boxes are made with card. The boxes are similar cuboids. The smaller box has height 32. It takes 44% more card to make the larger box. If it takes 44% more, then you can tell that that's talking about the area. Yeah? So you can tell the scale factor of the area will be 144% because it'll take 44% more card than the original 100%. So you've got 144% divided by 100. So you can tell the scale factor of the area will be 1.44. All right? Yeah. And we have to work out the height of the larger box. So now we know when we go backwards, the scale factor of the length would be the square root of 1.44. And we know the square root of 144 is 12. So it'll be 1.2. Yeah? So the height of the larger box, we're going from smaller to bigger. So it'll be 32 times 1.2. which will be 38.4 centimeters. All right, yeah, good. Okay, next. 2 similar pyramids A and B have surface areas 180 centimeters squared and 80 centimeters squared. So that's the area. Yeah, so the scale factor of the area is 180 divided by 80, which is 2.25. All right, the volume of pyramid A is 810 centimeter cubed. And we have to show that the volume of pyramid B is 240 centimeter cubed. Okay, so we have to find the scale factor of the volume. But before we do that, we have to find the scale factor of the length, which will be the square root of the scale factor of the area, which was 2.25, which is 1.5. So the scale factor of the volume will be the scale factor of the length cubed. Yeah? And if you multiply, or if you then divide the 810 divided by 1.5 cubed, which is the scale factor of your volume, you get 240 centimeter cubed. All right, yes. So you can tell all these questions look different, but they are so similar. That's all for now. I hope those questions were really helpful and easy to understand. If you don't understand or you don't feel comfortable, please watch the video again, and pause, try it on your own, and then see the workings as I've laid them out. And once it clicks, that's it. Yeah? All right. Join me in part 2 for some more interesting questions. And remember, you're in control. Keep practicing more questions, and everything will be brilliant. All right. Take care. Until next time. Bye.